be asked in the exams also. So let's have a quick view of the questions that can come into the exam. Like, what do you mean by a signal representation? Or it can be asked like write short note on the graphical representation of signals, mathematical representation of signals, or tabular representation of the signals. And third way, it can be asked that what is the difference between time domain and frequency domain representation of the signals. So, what is the meaning of time domain representation? What is the meaning of frequency domain representation? We are going to cover it in this lecture. Question can come: what is the difference between discrete signals, digital signals, or and continuous signals? Explain classification of the signals. So, this all can be the questions. Other thing now, let us see what is the communication system. It's important, and communication is the part and parcel of the every life, and it is the way to transfer an information from one thing to other thing, one place to other place, one person to other person. The devices, the electronics used for communication is called the communication system. The electronic system or the assembly of all the devices of electronics that are used for the purpose of communication is called communication system. The information to be transferred can be in the form of sound, it can be in the form of temperature, it can be a text, it can be image, it can be video, it can be any color, anything. So the anything which conveys information is called signal. So and this representation, that how to show it on the paper, is called signal representation. Okay, so the representation of the information in the terms of amplitude or voltage or current is called signal. Let us have a quick look over the entire communication system. The communication system consists of information source, then conditioner, and then the transmitter. After transmitter, information goes into the channel. In the channel, noise channel means it can be air, it can, if it is a wireless system, it can be a cable if it is a wired system, and the noise is introduced into the system in this duration in by this by the in the communication system in the channel only, and after passing through the channel, the information reaches to the receiver, and then here the procedure of recovering back, the information is recovered back, noises are removed, and it is given to the original form with the help of output transducer. So the signals, the information here, it is a signal, and information converted back is also a signal. Everything have some signals. Main information which is transmitted in the communication system is called signal. Signals are the representation of information. These are used to transfer information from one place to other place using a communication system. The examples for signals are electrocardiogram. It is basically used to detect heart diseases in the humans. Temperature with respect to time, temperature variation of a place with respect to time, pressure variation with respect to time are the examples of signals. Signals are analyzed in time domain. Also, they are analyzed in the frequency domain. So, what is the difference between time domain and frequency domain? If signal is represented with respect to time, then this is a time domain signal. And if signal is represented with respect to a frequency, and then this is in the frequency domain. Signals can be transformed from time domain to frequency domain. This is a time domain and this is a frequency domain, or vice versa. They can be transferred back from frequency domain to time domain. So the conversion from time domain to frequency domain is done with the help of Fourier transform, Laplace transform, jet transform, etc. The theory behind this, the signals, is very ancient. The story starts with the very long back in the 5th century BC. Panini, yeah, uh, who had given the rise of modern mathematical notations, recursions, and the transform theory started here. Aryabhatta provided the Sulb Sutra, sine and cosine theory, and then Barahmer, one of the very good, very broad-minded mathematician, who extended the work of Aryabhatta for the astronomical purpose. The sine and cosine has been used for that astronomical analysis. And then there are Sur Siddhanta. Basically, the ancient time they were mainly focusing on the astronomical analysis with the help of the mathematics. So the signals were used to analyze these mathematics. In modern days, there are many scientists who have given the theory like Fourier transform is given by the Fourier. That is the expansion of the sine and cosine theory. He worked on he generated the equations for this Fourier series and Fourier transform with the help of heat propagation equations. Then Cooley and Tukey collaboratively have extended the work of Fourier and given the fast Fourier transform. Modern signal processing, the complete work is with the help of these two persons, James William Cooley and John Tukey. Later on, a scientist came, name was Laplace, and Laplace have given Laplace theory, which is very useful for the analysis of the uh, the circuits, electronic devices, electronic signals, communication systems, etc. And then Hurwitz, we told Hurwitz, he had given jet transform, which is also useful in the digital signal processing or digital communication systems. Okay, so let us go come back to our main purpose, which was the signal representation. So signals can be represented graphically. Signal can be represented mathematically, they can be represented in the tabular form. Graphically, how a signal can be represented? Suppose you have a signal y equal to t. This can be this is a straight line. So yt in the y-axis and t in the x-axis, and this will be the representation of graphical representation of this signal. And this line is going up to infinity. A mathematical representation yt equal to t. This is a mathematical algebraic equation. And tabular representation yt equals to 1, 2, 3, 4, 5, 6, dot dot dot. That means at first point at t equal to 1 is 1, at 2 is 2, 3 is 3, like this. So this is a tabular form. When it is represented in the form of numbers, then that is a tabular representation of a signal. And in the tabular representation, origin point should be represented by an arrow. Okay. So this is how signal is represented in the three different form: graphical form, mathematical form, and tabular representation. Now there are some classes of signals: continuous signal and discrete signal, digital signal and analog signal, even signal and odd signals, like that. So you can continuous signal means when there is continuous values of the signal with respect to time. Discrete means if the values are only at discrete points, then this is a discrete signal. Yn represented, n is a discrete number, and at every point sample is taken. It is not continuous. Okay, digital and analog. Digital means if we define a level, then that is digital signal. Analog means the variation is continuous in this, then that is a analog signal. Even signal and odd signal. Even signal is like this, which is equal with respect to y-axis, and odd signal is one which is equal with respect to the origin. It gives a mirror image across origin. Then that is a odd signal. Periodic and aperiodic. Periodic means one which repeats after some time. Aperiodic is one which does not repeat after some time. Simple. Periodic means the signal repeats after some time back to its original value, and aperiodic means if signal doesn't repeat back to its original value. Okay, this time up to this point only. Next time we will see more details in the communication system. Thank you. Thank you so much.